From real world, we can draw some examples which help us to provide quality of service. From that perspective, we look at an algorithm called the classical leaky bucket algorithm and its manifestation as a token bucket. Specifically, we shall see what does leaky bucket mean, how is it meant to provide flow control and congestion control in the network, how does it operate, and then we shall see how token bucket as a specific example of leaky bucket works and how does it give us performance bounds to combat flow control and congestion control issues. The references that I chose for this particular topic are Broadband Telecommunication Handbook by Bates Regis J, William Stallings, High Speed Networks and Internet, Performance and Quality of Service. The ebooks of these are available on the internet, and these books are also widely available in the market. So, what is leaky bucket? Leaky bucket, as the name suggests, would be a bucket with a hole punctured in the base of it. What is it used for? It is used to buffer the incoming packets, and the packets are coming at a rate which is more than what the receiving side can bear. The bucket holds or buffers them till the incoming traffic fills up the bucket and the outgoing packets are received in a very smooth and regulated manner on the receiving side. So, the buffer of the traffic is meant to provide management and control of the flow of traffic. The term leaky actually means that the bucket actually has one input, unregulated and very large, but the outward flow is only leaking or dripping. It means that the bucket, because of its size, is able to contain the incoming packets and is controlling the flow of outgoing packets on the basis of the size of the leak or the puncture on the base. How does it work? The traffic which enters into the buffer is tagged. It means it is marked according to the traffic class it belongs to and the total number of packets that it is allowed to send into the network. If the sender of the traffic, which is the user, exceeds the amount according to the rate it is given in the service level agreement, then the buffer starts getting filled up because the incoming rate is more, but the agreement or the contract was for lesser packets. So the buffer starts getting filled up and it gets emptied slowly on a drop by drop or bullet by bullet, or I would say as a droplet by droplet. We can look at leaky bucket illustratively and compare it to its implementation in computer networks. On the left hand side, you see a real world bucket with the tap fully opened. So the tap is uncontrolled and it provides flush of packets, that is water, coming in. The bucket starts getting filled up. The flow of the bucket is dependent upon the leak size on the base, and it is going to allow drop by drop packets to be released. If we compare it to its implementation on a physical network, we'll see that we have a computer that is generating data at its own rate, but since the rate at which the network agrees to forward its packets is not exactly what the host computer is generating, so how can this be handled? This can be handled by a software program implementation on a router that implements kind of a leaky bucket as a software program. It starts receiving all the packets, and these packets get accumulated, buffered, or stored temporarily in the bucket, and the router only emits or allows a regulated flow of these packets one by one. So it means any uncontrolled or unregulated flow can be converted into a regular flow by the use of a leaky bucket algorithm. In order to implement leaky bucket for different users, each with its own requirement, one fixed size hole in the leaky bucket is not good enough. What we need to do is we need to provide a smart mechanism that controls the flow of packets on the basis of different requirements from different users. For that, the concept of token bucket comes in. The token bucket is a leaky bucket, but the only difference is the outward flow of the packets is dependent upon the tokens that particular user or sender is allowed to have. So many different sources can be provided different behaviors on the same leaky bucket by providing them tokens. So it helps us to provide specific descriptions of the load which is imposed by the flow, and it is easy to determine these resource requirements because depending upon a better service level agreement such as a gold service or a platinum service, more number of tokens would be assigned to that user. But if that user only has silver or a bronze service, it would be provided with lesser number of tokens. Practically speaking, the token bucket implementation is done through a policy. This policy becomes part of the QoS policy framework implemented in service level agreements for each user. So the user requirements or the parameters are mapped onto the policing functions. This policing helps to regulate the flow. The IP packets may only be processed for any user that is generating data and the data is arriving in the leaky bucket if there are enough number of tokens available for that particular user. If the user is generating more packets than its specified tokens, the packets are treated as best effort. It means in case the buffer overflows, the packets would simply be lost. On a physical router, in order to transmit a packet, a token per packet is defined, and each time a token is utilized, the packet is forwarded. If there is a backlog of packets and then the packets are coming in and filling up the bucket, the overall impact would be that the packets are coming in unregulated and the previous packets are also present in the bucket, the outgoing flow would be smoothened. So any misbehaving or irregular flow would be regulated. The token bucket algorithm is nothing but a leaky bucket algorithm figuratively, but with the inclusion of tokens. So the token rate is equal to R octets per second. If the bucket size is B, it means that in a specific time interval T, the amount of data that is sent by the user should not exceed the overall bucket size and its prescribed rate. Because if it violates either the bucket size or the prescribed rate, the buffer is going to overflow and the packets would be discarded, and only best effort service can be achieved through this mechanism.